Hello, ladies and gentlemen. Welcome to Skill 14B, which is Systems Word Problems Day 2. So today we're going to be really bridging the gap between our normal Delta Math systems word problems and some of them that you'll see on the SAT. And they're actually not much different, maybe a step of reasoning a little bit more. So one of the things that I will kind of show you is a problem that I like to call the coin problem. And they actually have a exercise on Delta Math where you actually can play around with like the different combinations of coins. And this is a good situation to show with like a graphical relationship how to solve a system like this. So Sarah has $2 worth of dimes and quarters. So a dime is 10 cents. And a quarter is 25 cents. And we just write that, of course, in decimal form. And she has a total of 17 dimes and quarters all together. So for this one, we're actually not going to write equations yet, but we're just going to kind of show you graphically. So the first thing that we could kind of think about is how do we get 17 coins? What are the possibilities? And we're not going to do every single possibility, but we're just going to kind of illustrate here. So I have 17 and 0 for my first one. So I could have 17 dimes and 0 quarters. And then for my second one, I could have 16. And if I have 16 dimes, that means I need to have 1 quarter. And if I have 2 quarters, that means I need 15 dimes to get my 17 coins. And maybe I could do like 14 dimes and 3 quarters. And we could even just write these in coordinate form, and you'll be asked on the next page to graph them. But we can kind of see a pattern that every time we go down a dime, we go up a quarter. Now, where things get a little bit more interesting is how do we get the combinations of $2 using the combinations. And I did make one small typo here. It turns out that if you have 1 quarter, you don't get an even number of dimes. So we're just going to do, maybe 2 quarters and 4 quarters. So 0 quarters obviously is $0. And then this would be like 50 cents. And our goal is to get all the combinations here of how we get to $2. So if I'm at 50 cents for my quarters, that means I need $1.50 for my dimes in this scenario. So that's the same thing as 15 dimes. And then we can kind of see that we went down by 5. So we'd probably be going down by 5 again. So 4 quarters is $1. And then I want $1 worth of dimes as well. So that would get me to 10. And of course, we could write our coordinates. So one way that you could solve a problem like this is just graph them. So we're going to actually demonstrate that on the next page. And we're going to label our axes to where the X value is dimes and the Y value is quarters. And we'll just go 1 dime or 1 quarter per square. And we kind of get the pattern here. So we're just going to go every 2, 2, 4, 6, 8, 10, and so on. So the first example, we had like, 17 comma 0 as a line. And then we also had, like 16 comma 1. So this slope has, kind of like -1. And you're even okay to get like 2 points because it's a pretty straight line. So I'm just going to make that, a slope of -1. And we'll just try to get it so that it covers all the squares. It's not perfect, but it is a nice straight line. And we want to also do the same for the $2 combinations. So one way that I could get $2 is I could have 20 dimes. So I would call that like 20 comma 0. And maybe then I could have 15 comma 2. And I could have 10 comma 4. And I'm going to connect my dots. And if it asks us how many dimes and quarters there are, the solution is 15 comma 2. So this would be 15 comma 2. So 15 dimes and 2 quarters. So if you forgot about like how to do a word problem scenario, one way that you could kind of like fake it on the SAT is, kind of like do those table of values and run it through like a few hypothetical scenarios. And you could even like graph and see what it looks like and come up with a solution. Now, the next question that we may be thinking about here is how could we be a little bit more efficient in coming up with this? So you could actually create a word problem. So maybe we let X be number of dimes and let Y be number of quarters. So I know that I have 17 coins. So I'm going to have X plus Y equals to 17. And then a dime is worth 10 cents. So I could say that 0.10x plus 0.25y equals to $2. So this is my cost equation. And then this equation is number of coins. And we could use after that substitution or elimination. Okay, let's take a look now at the next problem. So it turns out that there actually is a SAT problem related exactly to this. And they're not going to make you solve it, but they're going to make you come up with a system of equations. So we have a person named Jacina who has 80 cents worth of nickels and dimes. One thing that we can observe is that the bottom equations are all the same. So that doesn't really help us, but we can look at this top equation. It does give us a hint here that she has 4 more nickels than dimes. So what that means is that D plus 4 equals N. So I have N equals to D plus 4. And I can actually look at my answer choices and see, is there that answer choice? And it turns out that there actually is, just kind of written in reverse. So we would say answer choice B. So you actually don't even really need to think about the second equation too much. You just have to kind of zero in and translate into plain English into the math equation. All right, let's look at example 3. This is a delta math comparison question. So this is which is greater. So it gives us that we have an initial fee of $100 for company A at 150 per mile driven. So if I'm looking at A, I would write this equation as cost equals to, and we'll call X number of miles driven. As evident by what it says here in this situation. And then C is just cost. So I could say that the cost for company A would be 100 plus 150, $1.50 M. And then for company B, we're also looking at the cost, and it is kind of cheaper initially for company B. So we would say 40, but it's $3 per mile driven. So that's kind of brutal. And what we can kind of see here is we have two equations with C. So if I wanted to, I could kind of like see, you know, the break even point. So that's what I'm going to kind of look at, the break even point. And technically speaking, this is a system of inequalities. And you could, if you look at the answer key, you could see that I kind of used an inequality. But even if you don't think in terms of inequality, you could even do like reasoning on your own. But it says, I want company A to be cheaper than company B. So I'm going to say that A needs to be less than B. And I can just substitute the two equations. So instead of doing elimination, I'm going to substitute the two equations in. So I'm going to say 100 plus $1.50 M is less than company B, which is 40 plus 3M. And we're just going to subtract 40 on both sides. So I'm going to get 60 plus $1.50 is less than 3M. And I'm just going to subtract the $1.50 again on both sides. So I'm going to get 60 is less than $1.50 M. And I'm just going to divide by 1.5. And remember, we have just positive division, so we don't have to worry about the directions of the sign changing. And this effectively makes it so that I'm doing 60 divided by 1.5. 40 is less than M. And we need to kind of change this so that M is greater than 40. So after 40 miles or so, it is worthwhile to go with company A. All right, I'm just going to explain the rest of these problems. So for you try today, what we're going to kind of give you is a very similar situation to what I had above. And this is what you're going to see on the SAT. And they're actually going to take the advantage and kind of use like the same data set for 3 questions. So maybe they give you like, you know, what's the equation for company A? And then maybe on number 2, it's like solving the inequality in the style of what we did before on question 3. And then they'll ask you maybe an interpretation question. So, you know, what does the slope of a graph mean? And I'd like you to be thinking about that as you navigate through your U-Try. So thank you very much for tuning in. and good luck.